So let me share my screen. Obligatory, can you guys see my screen? Let me pull up chat so I can keep an eye on that. All right. So let me get my notes set up here. The first thing I want to do today is we have a couple of commands now. Let me get the last command we wrote in here, the drive distance command, and I think I'll be caught up. For those that don't have drive distance, it's in the Romi chat. Everyone else, I think, should have it. Oops. Get it compiling, and then we can do what we need to do today. Come on, import it for me. Come on, you can import it, you can do it. Okay, great. So we have a couple of auton classes now, right? We have drive distance, we have drive forward. Do we have any others? Am I missing any others? I'm going to take your silence to mean no, I'm not missing any others. So we have these two commands. We're going to go ahead and get rid of example command. We don't need it anymore. We have plenty of example commands. We can just move that to the recycling bin. So what we want to, and after you delete example command, go ahead and delete the object example command within robot container. And then delete the import. Both of them should be red and squiggly. And looks like I have an extra import here, so I'm going to go ahead and get rid of that. Okay, so what we want to do here today is create a selector. Oh, looks like Hannah dropped. Should I wait? Okay, she's back. Awesome. Okay, so what we want to do today is create a selector for our two autonomous commands so we can switch back and forth between them. So in order to create that, we want to create this object called Sendable Chooser. So it's going to be private. Is the font big enough for everyone? Should I make it bigger? Don't all say.
Could you make it a little bit bigger?
Better or more bigger?
That's good.
All right, perfect. So we're going to make an object of type Sendable Chooser. Sendable Chooser allows us to put a drop down within the smart dashboard. For those that don't know, the smart dashboard is basically when you're on the field and you want to connect to your robot, you connect via the driver station. And then another screen comes up, which is a smart dashboard. And then you can program in buttons and lists and put in gauges. So it's basically a dashboard to your robot. Here, our dashboard is kind of simulated. It's that purple screen that comes up when you press F5. And we'll be able to simulate the smart dashboard options within that purple screen. So we're going to make a Sendable Chooser object. And note what I did there. I started typing, and then I found Sendable Chooser. I highlighted it and pressed tab. And what that did for me is it imported the object reference. Sendable Chooser lives in this folder, edu wpi first, this directory, sorry, not folder. So whenever I start typing and I press tab, it'll auto import for me. That's one of the many features of an IDE. And we're going to use this angle open bracket. So this angle open bracket represents, it's part of generics. So basically, we want to tell Java that Sendable Chooser is going to be of type what. So if we control click into Sendable Chooser, we can see that it's public class Sendable Chooser, and then it has this angle bracket open V angle bracket close. That represents, this is called generics. And basically, V represents an arbitrary object. We can reference an arbitrary object here, and sendable chooser will kind of be of type V. And this is so that it can compile more intelligently, and you're basically telling the programming language what type of object we're going to be using with sendable chooser. So we're going to be using of type command. So it's going to be a list of commands, right? We have two commands. We have drive distance and drive forward. We want to have the list of commands. So we want the sendable chooser to be of type command. And we're going to call it chooser equals, and we're just going to call it new sendable chooser. So we've initialized a new sendable chooser object. And whenever you have this generics concept, you only have to define the object within the brackets once. The second time, it's kind of optional. You just have to define the open close angle brackets. You don't have to write command again. It's implied that this sendable chooser is going to be having command within this angle brackets because you defined it once. It's just saving you a little bit of typing. Okay, so we've created a command. We've created an object, called chooser, which is of type sendable chooser. And it's going to be a list of commands because we put command in the generics brackets. Let's see if we can pull up a better definition of generic methods. Let's see. It's called a type parameter, generic method. Oh, we're looking at generic methods to see if they talk about generic classes. We can use this. We can use this. So make it bigger. We're not talking about methods. We're talking about a class here, but it's really the same thing. We're giving a type declaration, a type parameter. So if we command click into sendable chooser, you can see it has a type parameter. In this case, when we define the sendable chooser object, which the object name is chooser, we're defining that the type parameter is of type command because our sendable chooser is going to be a list of commands. Okay, so we've defined our object now.
Hey,
now
Kush,
what we
can I
want
pause
to
you for just one moment.
absolutely.
I think so you guys have seen Kusha pull up documentation and instructions and manuals. This is very common. This is not just common. This is the way that programmers work. You normally have your IDE open on one screen and 10 tabs of documentation and explanation and specifications on other tabs. Coding is open book, always, except if you're Nathan. And even then, they have reference books. So that's totally cool. Or if you're taking a test, that's not open book.
Yeah, that's absolutely right. So like, I'll show you guys what's on my other screen. So on my other screen, so I have this generics page pulled up because I can't explain generics without having a cheat sheet. You saw me struggle without this page. I have another VS Code project pulled up that has all of the things we're working on already written out for us. You can see that the sendable choosers here. I also have open our infinite recharge project. So this is the infinite recharge project, so I can reference that. And you saw me whenever I'm coding with you guys, I'm command clicking into stuff so we can read what the potential comments are on that class. So it's absolutely open book, and even simple things, seasoned programmers are Googling how to do them. No one memorizes how to do things. It's software engineering is about knowing how to get the information and then apply that information. It's less about memorizing all the information and spitting it out from your brain. Did I do that justice, Stuart?
Yeah, it's great. Stack Overflow is great.
Absolutely. Yeah, I was looking at Stack Overflow before this. Okay, so we created this object of name chooser, which is of type Sendable chooser, and it has a type parameter command. The type parameter just defines what kind of object Sendable chooser is going to be working with. In this case, we're going to have a list of commands, so it needs to be the command object. So in our robot container constructor now, we would like to add some options. Let me pull up my notes. I messed up my other screen. So within our robot container constructor, and let's remember that the constructor is called when the robot container object is initialized. When is the robot container object initialized? Well, it's initialized in robot base, I think. We're not going to get into that, but basically robot container gets booted up. There's one robot container that kind of exists when you run your project, when you connect to your robot. So this is run once. So when this is run, we want to add some options to our chooser object. So let's give it one option. The two options we want to give it are drive distance and drive forward. We can give it a default option, and then we can add an option on top of that. So let's go ahead and do chooser dot set default option. And notice what I did there. I started writing out chooser, and I pressed dot, and it gives me all the methods on chooser. So if I go to Sendable chooser, it has all these methods, right? And it's going to even have more methods than what's defined in here because it implements a couple of other classes. So whenever I type in chooser and I press dot, you can see everything that I can select. We want to select set default option. So what do? I start typing set default option, and it comes up, so I can just press tab. And then it gives me some helpful hints of what I need to pass in for the set default option method. What's in the set default option method's signature? And remember, it's method and function are interchangeable. They mean the same thing. So we want to give this a name. And then if we hover over set default option, we can see that the first parameter is a string. So we want to pass in the drive distance command. So let's name this drive distance. And I don't have the drive distance object, so I need to create that. I think you guys already have the drive distance object. Drive distance equals new. And then what does the constructor take in? It takes in a speed. And then it takes in a Romi drivetrain. And it takes in distance in inches. So let's say 12 inches. Don't forget our semicolon. So we have a drive distance object. It's yelling at me, so probably need to import it. Go ahead and import drive distance. Now we have a drive distance object. So going back to our chooser method of set default option, we've filled in the first parameter of the method signature. Now we need to figure out what the second parameter is. So if we control hover over set default option, it tells us the first parameter is a string, which we gave it a string name, drive distance. Now we need to pass in the command object. So we have this drive distance object up here, and I think you guys already have this, by the way. So I'm just going to go ahead and pass in the object. Great. So now our default option for our chooser object, which is of type Sendable chooser, which takes in a type parameter of command. This default option is now drive distance. Let's give it another option. So again, we're going to do chooser dot. This time we've set the default option, so we're probably just going to add an option. And we can see right here, it says add an option. And the signature of add option is the same as the signature of set default option. So let's go ahead and click on it. And this time we're going to do drive forward. And I already have the drive forward object, and I'm sure you've guessed it here, but we're going to pass in drive forward. So the last thing you need to do, and this isn't very apparent, but we need to put the sendable chooser onto the smart dashboard. So let's go ahead and write the code for that, and then I can kind of explain what's happening with that code. So go ahead and start typing smart. The first option that comes up should be smart dashboard. We're going to press tab. I press tab because it'll import it for me. If I didn't press tab and I just wrote it out, it's going to yell at me. It's going to say smart dashboard cannot be resolved. So I'm going to have to import it. Will it let me import it without typing in the rest of it? It won't. So lesson here is press tab as often as possible. Okay, so we're going to say smart dashboard, which references the smart dashboard object, and we'll talk about why we're not setting up a smart dashboard object here and instead calling the smart dashboard object. And we're going to do put data. And we can see when we start typing in put data, the signature for put data takes in a sendable. Sendable chooser is partially of type sendable. We can see it implements sendable. So it's absolutely valid to put in a type sendable chooser in place of sendable. So we're going to put in chooser. Okay, so let's talk about why we did smart dashboard here instead of doing something like smart dashboard dash equals new smart dashboard or whatever. So within the WPI lib library, smart dashboard is a static object that exists. The reason it's a static object, let's talk about what is a static object. Static just means that it's created once and there's only one instance of it available within our project. The reason they've made it a static object is because we're not going to have multiple smart dashboards. It's going to be real confusing to try and piece together which smart dashboard object to use with our program, the smart dashboard. So it's static because there's only one instance of it and it's a global instance. So that's why we just referenced the class name .put data instead of creating an object for it. All right. So now we can go ahead and one last thing we need to do here is we remember this. Y'all remember this get autonomous command method that returns a command, and then within robot we have this autonomous init, which actually calls robot container.get autonomous command. Right now it's returning drive forward for me. I think for you guys it's returning drive distance. Instead of returning an object here, we want to return the output of what we've chosen from our sendable chooser. So what we can do here is instead of returning a command, we do chooser.get selected. So now we're returning the selected command from our sendable chooser, and we know it's going to be of type command because we set the type parameter of sendable chooser to be command. And if you hover over get selected, we can see it's returning a type command. Okay, so now if we go ahead and run our robot container, and I encourage you guys to connect your Romi robots here to Wi-Fi. I just want you guys to test it out, see if this works. And I'm going to show you guys how to add this sendable chooser to your dashboard because it's not very apparent. So we made that list. It's not here. What we need to do here is once you open up this robot simulation program, you have to go to network tables at the top, go to smart dashboard, and we'll see this sendable chooser that we created within the list of smart dashboard. If you click on it, it's going to give us a dropdown of drive distance or drive forward. I don't have my Romi connected right now, but what I want you guys to do is get this list up, select drive distance, and then press autonomous. See if it drives a distance. Disable it again, select drive forward, and then select autonomous again. Let me know when you guys are done with that. Okay, Sorry, Eden, I didn't see your chat. You're getting a weird warning. Add object is... so we didn't do add object, we did add option. I think that's where your issue is. It's add option, not add object. Alexa and Eden, let me know when you guys have tested the chooser and it works with your Romi. I'll see if I can fit everything on one screen. I'll move this up so you guys can see everything we talked about. So this is the object. Okay, Eden, no problem.
Wait, nothing's happening. Like when I press function 5, it doesn't do anything.
Can you share your screen?
Yeah.
Stop sharing.
There.
Okay, go ahead and save your robot container. You see how there's a white dot? That means your robot container.java has not been saved. Oh, it looks like she froze.
Okay.
Welcome back.
My Wi-Fi got confused with the two different ones. Okay. Yes. Ta-da.
Okay, so what I was saying before is that do you see the white dot on robot container?
Yes.
You know what
Oh,
that represents?
yes. I need to save it, but it's not working. Oh, there we go.
Can you scroll down to the get autonomous command method? Okay, so we talked about what you need to return here, right? Right now you're returning drive distance, but what we want to return is the output of our sendable chooser. Do you remember how we did that?
Not exactly.
So let's go ahead and just start with the object chooser because it's going to be some method off that object, right? So start typing in chooser and then put a dot. Okay, now we can see all the methods available to us. So out of this list, can you see if you can guess which one we would need to pull the selected command off of our chooser?
Is it get selected?
That's right. That's exactly right. All right, so let's go ahead and save that. Now go ahead and press F5. Give it a second for it to boot up.
Oh, here we go.
Did the screen come up?
Yes.
Awesome. Do you know how to add, I can't see the screen by the way, but do you know how to add the chooser to your robot simulation?
No. Here, should I stop share? I think I can stop share and then.
Perfect. So go to network tables. Go ahead and press disable. Go to network tables. Sorry, the network tables menu. Yeah. Under smart dashboard. Go to smart dashboard. You're on your live window. Click on Sendable Chooser. That's the chooser object we made. And now you have a list of your autonomous commands. So you can select an autonomous command here, and it's going to select that object. Your get selected is going to return the object you choose. And then when you press autonomous init will run, and it will get the object you've selected in this list.
Oh, okay.
And when we compete next year in our competitions, selecting I'm on the blue side and want to go for the low goal from the dashboard is so valuable. Games are won with the Sendable Chooser.
Okay. It did not work.
Is your Romi connected to, are you connected to your Romi via your computer?
I believe so. Oh, no, it disconnected. Okay.
If you're not connected, you need to close this window and rerun it after you connect to this Wi-Fi, to its Wi-Fi,
Okay.
excuse me.
Okay. Okay.
You got the reply, Stuart?
I don't understand the question.
I got it.
Oh, I thought she was trying to select her Wi-Fi. I'm sorry.
All good. At least I hope that's what she's asking about. I'm gonna go grab some water. Did it work, Alexa?
I just got on to the Romi Wi-Fi and I just pressed F5. It's still loading.
Cool.
Oh wait. Oh, there it is. Yay, it worked.
Now try to disable it, select the other one, and then select autonomous again.
Yay, it also worked.
Awesome.
It drives so peacefully. At least on carpet. It looks very nice.
We're waiting on Eden, and once we resolve her issues, we'll move on. Welcome, welcome, Eden. Share your screen so we can diagnose your issue. Okay, so sorry, it wasn't very clear. What I meant by network tables menu is in the upper part of your screen, very top part of that one, and then press Smart Dashboard, then press Sendable Chooser. Perfect. So you can select one of these commands and then press Autonomous while you're connected to your Romi, and it will run that command. Then you can disable, select Autonomous again, and it'll run that command. We need to get you a Wi-Fi stick so you can be on Zoom and connect to your robot simultaneously. Are you going to hop off and do that real quick? Okay, cool. Welcome back, Eden. Did it work? Awesome. So what I would like to do now is basically walk through kind of a visualization. Let me open up chat so I can keep a better eye on it. What I would like to do is kind of create a visualization of everything that's going on with this Sendable chooser and how we're getting the right object and what's going on, why you have to disable and then re-enable. So hopefully this diagram that I'm going to attempt to do here will give you a better mental model of what's going on. So what we're first going to do here is create a box for our robot. Let's make this bigger, and then we can flip back and forth between this screen and the code as needed. So this big box here, we're going to make this transparent. We're going to name it robot. Robot app, okay? This is the entire robot application. We're going to move this label to the bottom. Can I do that? Yes, I can. Awesome. So we have our robot app, right? Within our robot app, we have, my screen froze. This is unfortunate. Okay. Within our robot app, we have two classes. Here we have robot container. Let's make this, let's make this bigger. And then we're going to copy this and we're going to paste this. And we're going to have another class called robot. All right, let's make these both transparent. Let's move the text to the bottom. So we have robot. And then we have within our app two more. So all I've done here is, this is a robot app. We've identified that we have robot.java and robot-container.java within our app. So then within robot container, we've defined two other objects. And this one is called drive distance. And we're going to put in parentheses command drive forward command. So object, 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 object. These two objects live in this object. And feel free to interrupt me anytime you guys may have questions. And we'll make these green because colors are fun. So we have these two commands. Then in robot container, what can we do? How can we define a method? We'll use this for method. Within robot.java, we have this method. So let's go back to the code real quick and talk about what we've written so far. So we have our two classes. We have robot.java and robot-container.java within our robot app. And then within robot container, we have two objects defined in it, one called drive forward, one called drive distance. So now we want to define this autonomous init method. So going back to this, within robot.java, we have this autonomous init method. Let's make this, let's do this. You have this autonomous init method. We know it's a method because it has the parentheses open, close. Since these are objects, we're going to give them the object name. Robot container and robot are methods, but, or I'm sorry, objects, but it's not very clear how they're instantiated. So we're just going to pretend that they're instantiated by the robot. It's done by WPI-lib. Go ahead, Alexa.
I think your autonomous and it says anonymous.
I can't spell.
It's okay.
How do I spell it?
Just to make sure.
All right. I will copy paste so I don't get it. Thank you for the.
You're welcome.
I hate that it changes the font.
If you do Control Shift V, I think it's
I
pasted
tried
that
it.
format. Oh,
Didn't work. So we have autonomous. Thank you for the shout out. We have autonomous init command within robot.java. And then we have another, not command. I'm sorry, I said command. It's not command. We have another method within robot container called get autonomous command. We're gonna have to make this bigger again. This is my substitute for not having a whiteboard, so y'all will have to bear with me here. Okay, so then we have this other concept of a chooser. Within robot container, we have this sendable chooser object. So let's copy this. Oops. This guy, and then call this chooser, which is of type sendable chooser. And what chooser does, it looks at what you choose and picks the object that you chose. It holds the object that you chose in memory. So then autonomous command, get autonomous command, what it does. Sorry, I'm struggling a bit. Looks at this via chooser.get selected. So then in autonomous init, if we open that up, within robot, it gets robot container.get autonomous command. So all this guy does, can I do this? Is it gonna let me? Is look at that guy. So we can make robot app a little smaller. When you run, when you select autonomous init is called, which then calls autonomous command. Let me back up. You run your program. All of these objects get initialized. We have a robot object within our memory. We have a robot container object within our memory. We have this sendable chooser object named chooser within the memory. We have this command object named drive forward within our robot app memory. And we have this drive distance object, which is a type command within the memory. So you go to your smart dashboard, you select autonomous. It calls autonomous init. Anytime you select autonomous, it calls autonomous init, which then calls robot containers method called get autonomous command, which then calls our sendable chooser object, and it calls the get selected method on chooser. Really what I should have done here is this. To make this a little more understandable, what we can do is this. Sendable chooser has a method called get selected. And that lives within chooser. So get autonomous command is calling get selected within chooser. Just like robot within autonomous init, we're calling get autonomous command within robot container. We're calling the get selected method on the chooser class. I think that's the term I've been using. So then within chooser, it tells us, oh, you've selected drive forward. So it returns it all the way back to Java. So that's how the code is kind of flowing. And let's go back to this and walk through it side by side. Let's see if I can do this. Okay. Can I close this? Make that bigger. So we're in robot.java. Let me close everything. We're in robot.java. We're in the autonomous init method. And we can read up top of autonomous init that says, it says this autonomous, this is a bad comment, but it says this autonomous runs the autonomous command selected by your robot container class. So we can look in the autonomous init method that it has this command variable of type command. If we hover over it, it says it's of type command. And it calls the robot container object, which I totally got this wrong, guys. Let me correct myself here. Correct myself. Bear with me. Can I do this? Can I select like that? It's actually, I'm struggling. Give me a second. Okay. Robot container actually lives in robot.java. I'll explain why that is in one quick sec. And then we should delete this arrow, and I delete the whole thing. It's really hard without a whiteboard, guys. I'm really struggling. Okay, there we go. So robot container lives in robot.java. So we're in our robot app. We're in the robot class now. Within the robot class, we have an autonomous init method. And then we also have a robot container object within our robot class. We can see private robot container, M robot container. So robot container lives in robot. When you select autonomous, an autonomous init is selected, it's ran, which calls a robot container.getAutonomous command. It calls the method of getAutonomous command within the M robot container object. So autonomous init calls getAutonomous command. So if we control click into getAutonomous command, we're now in robot container.java. We're in this robot container. We're in this box now. We have this method called getAutonomous command. Here's the method. GetAutonomous command calls getSelected on the chooser object. We have this chooser object. It lives within our robot container class. You can see that the chooser object lives within the robot container class. We call the getSelected method within the chooser object. And then getSelected, these arrows are actually wrong. GetSelected will then return, come on now, come on, you can do this. Return one or the other object based on what you've selected within your dashboard. So this is the flow of what's happening when you select autonomous init. This is everything that's going on in the background. The reason you have to disable and enable your robot again is autonomous init is only ran when autonomous is selected. So once this happens, if you select drive, let's say you've selected drive forward and now you want to select drive distance, well, autonomous init isn't going to run again. The only way autonomous init runs again is if you disable and re-enable autonomous, which does this whole flow again. Any questions? I'm going to assume there's none. I'm going to assume that silence means none.
So the getSelected calls for either command within the chooser.
it's not within the chooser. So the objects live within robot container. They don't live within chooser. You can see that the objects are in robot container.
Right.
All it's doing is that we've passed in a reference of drive distance and drive forward to the chooser. Whichever one you select in that menu, it now says, oh, we want this reference or we want the other reference. Does that kind of make sense?
Yes.
To get really technical with it, each of these objects within your computer's memory have a memory address. Like your home address, they have a memory address.
Right.
So within chooser, we put in the memory address of drive distance and drive forward. So within that menu, when you select one or the other, it says, we want this object based on the address.
Okay.
And then it selects that object and passes it to get autonomous command.
Got it.
Any other questions? Okay, awesome. So we're going to move forward. We're going to do some more coding. What I want to do now is create 2 new command classes. The first command I want to create is called turn time. What I want turn time to do, oh, I'll definitely check that out. What I want to do within turn time is pass in a speed and a time, and I want it to start turning at that speed for that time. So can one of you guys volunteer and create that class? It should be pretty similar to drive forward. Instead of driving straight, we're going to be turning for that amount of time. So I want you guys to use this drive forward class as your cheat sheet and create a turn time command class. I can wait 51 more minutes until one of you guys volunteers. No pressure. If you guys really don't want to do it, I'll do it. But I think you guys can do it. You guys have everything you need within drive forward. I don't think you need me to write this command. All right, fine, I'll do it. But you guys are gonna tell me what to type. So I'm gonna create a new file called turntime.java. What is the first thing I need to do? And I'll be nice and I'll open drive forward to the side. So you can see both of them at the same time. What's the first thing I need to do here? Let me open up chat because I've been ignoring chat this whole time. Sorry, even. So what's the first thing I need to do here?
You need to write the extends command base part.
That's exactly right. Extends and base. What do I do now?
I just got an error. Oh, I need to import. Okay. Hang
I also have an error, but I need to be told what to do.
on. You have to import the command base.
How do I do that?
You can hover over it and then do the quick fix.
What do I select?
Import command base.
Okay, great. So now we know our class turn time, the class turn time, is gonna extend command base, which means we can use we can override some of the methods within command base. Great. So let's talk about our class parameters or class variables. Just like drive forward has a bunch of class variables, we need a bunch of class variables for turn time. So let's, before we jump into that, let's go ahead and comment up here what the heck turn time is going to do. So, by the way, these symbols are to create a block of commented code. So I can just type here, keep typing, and it's all going to be commented based on this opening comment block and closing comment block. So this command will turn your robot for, I'm cheating right now, a desired rotational speed and time. Let me open up word wrap. All right, so this command is going to turn our robot for a desired rotational speed and time. With that in mind, what are my class parameters?
Speed, time, and rotation.
Okay, so private, what kind of variable is speed going to be?
Double speed.
Okay, private double speed, private double time. Thank you, Eden. What else? Agreed. Private drivetrain, private Romi drivetrain. You've got the name and the type backwards there, Eden. So in your previous two, you got them correct. It's the access modifier, then the type, and then the name. So your last one should have been private, which is your access modifier, type, which is Romi drivetrain, and then the name, which is drivetrain. All right. And I made the capitalization just like you did in the chat. Let's keep that in mind. What else do we need? Do we need anything else?
Do we need the rotation?
Can you expand on that idea?
Like you could rotate in degrees or something.
So I don't want to rotate for a certain amount of degrees. I just want to rotate at some certain speed for an amount of time. It's
Okay.
going to turn our robot for a desired rotation speed and time. That's it. We're not turning a specific amount of degrees yet.
Okay. So then you need start time, right?
Agreed. I do need start time. What type is start time?
Long?
Can you tell me why?
Not necessarily.
Can you tell me why start time was long within drive forward? Look at where it's used within drive forward. Look at where it's set. That's where really we define what type it's going to be when we set it. So where do we set start time within drive forward?
In the initialize?
I agree. We set start time to equal something within initialize. We do system.currentTime millis. So what part of this line can give us a hint why start time is long? There's only so many amount of words here. You guess all of the words until you get it right.
Is it the system?
Close. So system is the class we're calling current time millis from, So the class isn't really going to give us the type, but it's going to be the return value of the method we're calling on system. So we're calling the method on system called current time millis. If we control click into current, let's not do that. If we hover over current time millis method, we can see that it's returning of type long. It returns the time in milliseconds. What type is going to be the time in milliseconds? Because, well, it's going to be of type long, which it says right up here. The reason it's not system is because system is the class the method current time millis exists on. System doesn't return anything. System just, you can think of system as hosting a bunch of methods.
Okay.
And just like smart dashboard system only exists once. It's a static class. So that's why it's just system.currentTime instead of system equals new system. Okay. So private long start time, right? Now what do I need to do? The answer is right on the right.
So we just made an object and now, like the whole public class thing, is that the class object?
It's just a class.
Okay.
So it's our blueprint for our eventual object. Eventually,
Okay.
within robot container, just like drive forward and drive distance, we'll define an object off of the class. So this drive forward object is created off of the blueprint drive forward, which is a class. So the class is the blueprint for the object. So it becomes an object when we actually initialize it and bring it into existence. Right now, we're just kind of defining it. Does that make sense?
Yes.
Okay. So what do I need to do?
Now we need to do public turn time.
Okay, and what is this?
I'm
Do you
not
know
sure.
that it is called a constructor?
Okay.
Is that ringing any bells?
Yes.
Do you remember what a constructor does?
I know it like sets the equals, like not define, but sort of like specifies.
That's exactly right. So basically, we can pass in a bunch of parameters here, and then usually we set the parameters passed into our class variables. Class variables, this is not real code, by the way, equals params that we pass in. The constructor is called, the constructor is called when the object is first initialized. So this is ran one time. So the purpose of our constructor, for example, within drive forward, is to define the speed, time, and the drivetrain object for our command. We set it one time so that every time we call this command, these are the parameters we're going to use. And then we set the class variables based on the parameters passed in to our constructor. It's like a method, except it doesn't have a return value, and it's called when the object is initialized.
Okay.
So tell me what I should do with this constructor.
So you need to write in your parameters, which is double speed, double time,
Romi drivetrain.
That's exactly right. So what now?
Hang on. And then, yes, that's it. And then set this dot speed equals speed.
Can you explain what that line is doing?
So now when you're typing in speed, it's like, I don't know, it's hard to explain.
Do you remember what this means?
I kind of like remember it as, I don't know if this is right, but it's kind of like a little thing that it's like a first name, so you can like separate the speeds from the this dot speeds, which I don't think that's right, but
You're sort of on the right track. So what this represents the class. You can replace this in your brain with the class name. So this dot speed, which would become turn time dot speed, it's referencing the speed variable on turn time. So if we click on this dot, we click on speed after this dot, we can see that it highlights the class variable speed because it's referencing turn time, which turn time and this are interchangeable. This represents the class that you're using it in. It represents turn time dot speed, which is the class variable speed. And then this, then the speed after the equal sign to the right of the equal sign represents the constructor signature speed because it doesn't have a this in front of it. So what do I need to do next?
then you need to set this dot double time. Wait, no, this dot time equals time.
Okay. Good.
And then this dot drivetrain equals drivetrain.
Perfect. What else?
Okay,
Missing
and
one other
then
thing.
the add requirements. And then drivetrain. And I think, do you need, no, never mind.
Can you explain what add requirements does within a command?
So it takes the requirements from the drivetrain command and like applies it to this.
You're on the right track. It specifies what subsystems are required. So if we hover over add requirements, we can see that it takes in a group of subsystems, so one to many subsystems. It defines what subsystems. We know Romi drivetrain is a type subsystem because if we control hover over Romi drivetrain, it extends subsystem base. So repeating myself for the third time, sorry. Add requirements defines what subsystems are required for our command so that if we happen to have multiple commands running concurrently, we don't step on each other's toes. Because a subsystem kind of defines what hardware we're interacting with. So we wouldn't want two commands running simultaneously or one after the other to interfere with the same subsystem. We only want one command to a subsystem. Okay, so what do I need to do now?
You need to write the initialize execute is finished.
All right, tell me what to do.
So add override. And then public void initialize. This dot start time equals system current time millis.
Can you tell me what that line is doing?
So it's saying it's saying the start time for this class is in the current time millis.
We're setting, you said the first part perfectly right. We're setting the start time for this class, which is turn time. So this dot start time represents this class variable. We're setting it to the return value of system.current time millis. We're setting it to the return value of the method current time millis. What does current time millis return? Well, if you hover over it, it says returns the time in milliseconds. What type is the time in milliseconds returned as? It's returned as a long. The method returns a long and it returns the time in milliseconds. So we're setting long start time to the current time in milliseconds when this command is slated to run, when the command is initially scheduled. All right, what now?
Okay. This dot drivetrain arcade drive. It's 0, 0.
That's exactly right. Can you tell me why we want to pass 0, 0 to arcade drive on Romi drivetrain, on our drivetrain object, which is of type Romi drivetrain?
Is that just like the starting position?
What does arcade drive do? Do you remember? Does it tell us? It does not. So let's look at arcade drive. Arcade drive is a method on Romi drivetrain. We're in the Romi drivetrain class, right? Class Romi drivetrain as a method called arcade drive, which return value void, so it doesn't return anything. It takes in two parameters. It takes in an x-axis speed and a z-axis rotate. You can think of arcade drive as taking in a steering wheel value and a throttle value. Like in your car, you press down on the pedal to make your car go forward, and then you give it a z-axis rotate value to turn. So x-axis speed is your throttle, z-axis rotate is your turning power. So when we say arcade drive dot 0, 0, what are we saying?
That it's not moving either way.
Exactly. We're saying that we're bringing the Romi drivetrain to a complete stop. And that's because let's imagine we scheduled turn time. Let's imagine that within our drive forward command, we didn't set this dot drivetrain arcade drive 0, 0. Okay. Let's say we forgot to add this line. So whenever we call execute within this command, we set it to this dot speed, and then it's finished, but we never set it to anything besides this dot speed. So the command is finished, but it's still going forward at a speed. So then let's say right after that command, we schedule the turn time command. We don't want it to be going forward. We want to bring it to a complete stop just in case it's still moving from a different command. It's a safety measure.
Okay.
Okay. What next? Great job so far.
Okay, then you do override.
Yeah, I agree. It's going to be the execute method, Eden. So I'll go ahead and write out that method as you correctly called out. What needs to go in the execute method, Eden? Can you tell me what needs to go in the execute method, Eden? Okay, sure. I'll paste that in. So, and my drivetrain is all lowercase. So can you tell me what this is doing? What this line you've told me to paste in is doing? And I'll pull up the arcade drive method on the right side so we can reference it. That's exactly right. It's moving. We're making it move. We're making it move forward. We're making the x-axis speed. We're making it move forward at this dot speed. But what is our command trying to get us to do? Is it trying to get us to move forward or backwards? Or is it trying to get us to turn? We want it to turn. You're on the right track. Right now, we've told our Romi to move forward or backwards, to move at a certain speed in the x direction. But what do we need to do instead of moving forward or backwards at that speed? What should we do? Remember, arcade drive takes in two parameters. It takes in a speed, which is your throttle going forward and backwards. And it takes in a z-axis rotate, which makes it turn. Right now, you've said, let's move at this dot speed for our throttle, but you've told it to not have any turn modifier. You're exactly right. The 0 needs to be something else. So, Alexa, do you have any ideas?
I feel like if you just put in like a number, you can see what happens.
Okay, sure.
Yeah. Either
You want me
that
to- Go ahead.
or or also could we set up another class variable to be the z-axis?
I'm thinking. Is what degrees or milliseconds? Z-axis rotate is a double, just like x-axis speed.
And it's probably, just because everything else seems to be, -1 to 1.
That's exactly right. Just like speed is -1 to 1, z-axis rotate is -1 to 1. So how about we do this? We'll take both of your suggestions. So your suggestion, Eden, was to do this dot speed, comma 0. Your suggestion, Alexa, is to do this dot speed, comma 0 point something, right? Give it a number. And we know that per Stuart's comment, the number for z-axis rotate is going to be between -1 and 1. So let's give it 0.5, okay? We pass in a speed, we make it go forward at that speed, and it's going to be rotating at 0.5. Then we'll see what it does and what we may or may not need to change when we actually get this command to run. What do I need to do next? Let's move on from execute. I agree. We need to override the isFinished method. So it is a method that returns a Boolean. The return value is Boolean, as indicated by this term, Boolean. isFinished. What should we return within isFinished?
We should return the system.current time millis.
That's not a Boolean. That's just a long number. A Boolean is a conditional. Remember, we made the same exact command, except the difference between this command and drive forward is that this command, we want the robot to rotate for a certain amount of time. The other command, we just wanted it to move forward for a certain amount of time. So it's essentially the same command, except it has one key difference, which is the robot will turn instead of moving forward or backwards. So what do we need to do within isFinished? Whether the current time minus the start time is equal to or greater than, that's exactly right. That's exactly right, Eden. We want to return whether the current time minus the start time, meaning the duration it's run so far, is equal to or greater than the time that we passed in, i.e. the time that we want this command to run. So can you put that in code for me? Okay, this dot start time is greater than or equal to this dot time. Okay, so can you tell me, can you put in words, Alexa, what you've told me to write here? Put it in English terms, don't read the code, put it in English.
So whether the time, like the current time, is greater than or equal to the time from the class.
So time from the class represents how long we want this command to run. We pass in time to specify how long we want the robot to turn. So this part of the conditional is correct. This dot start time isn't the current time. This dot start time is when the time when the command started running. So we need to use start time to calculate how long the command has been running and whether that duration is greater than or equal to this dot time. Does that make sense?
Yes. So whether okay.
That's exactly right, Eden. So we want to do system.currentTime millis minus this dot start time is greater than or equal to this dot time. And I like to put parentheses around those two, just to be safe. So we calculate here, this is the duration run. Look, we get the current time in milliseconds minus the start time of this command, and we compare the output of this subtraction. We compare to see whether it's greater than or equal to the time that we passed into the class, the time, the duration that we want this command to run. And is finished, execute runs, right? And is finished is constantly being pulled to see if execute should be ran. Does that make sense, Alexa?
Yes.
Good work, Eden and Alexa. All right, so I think we're done with is finished. So what do we need to do here at the last part of our class? Yep, you're exactly right. We want to define, we want to override the end method from the command base class. So it's override public void end, and it takes a Boolean interrupted. What do we want to do within our end method? That's exactly right. And can you explain what that line does, Eden? Makes it stop moving, exactly. Okay. So now what I want you guys to do is walk me through how we can add this, create a turn time object within robot container, and then add it to our drop-down list of autonomous commands that we can run.
Wait, could you repeat that?
I want to create a, so we finished our class turn time. So now I want to create, instantiate an object of type turn time within robot container, just like we instantiated an object of drive forward. And then I want to add the new object that we create of type turn time to our chooser, sendable chooser object, so that we can choose it and then have it run.
Okay. So we add the private final.
Private final.
Turn time.
Turn time.
And then is it just turn time again?
It is. So this first turn time, it's the class name. So the class that we're using is called turn time. The class that we're using right here is called drive forward. The name we're going to give this object is going to be drive forward. But we know that this is the class name because if we hover over the class name, it says frc.robots.command.driveforward. It shows us the package drive forward lives in. Whereas if we hover over the name, it just shows us what type it is. This is the type of object. This is the name of the object. So it's just going to be turn time again, because we like to name our objects in reference to the class name, so we know what we're talking about. If we gave it a name like X or hello or Kusha, we're not going to know what the heck that means. It's a silly name. We want to give it the name that it's referencing. So what now? Yeah, you're exactly right, Eden. New turn time. What goes after new turn time? Tell me what I should put in for the parameters. You're right that it is the parameters. What should I put in for the parameters? We can see the parameters it takes in. Oh, we have an error. Can you tell me how to resolve the error so then we can hover over turn time and see what parameters it takes in?
Import turn time.
That's exactly right. So it says it cannot be resolved to a type when you specify what package turn time is in within robot. We need to specify what package turn time is in and define that in robot container. So robot container knows where to look to get the definition of turn time. So we're going to import turn time, which adds this import up here, which defines the package where turn time is located. So now robot container knows where to look for turn time. So if we hover over turn time, it shows us the parameters it takes in. So the parameters that Eden wants us to do for double speed is 0.5. For double time, it's 0.5. And Romi drive, and we want to pass in the drivetrain object. So 0.5, comma 0.5, comma M Romi drivetrain. I'm just going to point out to you here that time is in milliseconds. So we're running, yeah, it's going to be running. You're not going to see this run. This is such a minuscule time. Yeah. So 3,000 would equal 1 second. All right. So now we've created our turn time object. It's going to theoretically turn at 0.5 speed for 3 seconds, which is 3,000 milliseconds. And it takes in the Romi drivetrain object we've defined in robot container. So now, what do I need to do with my chooser object in order to add the reference of turn time in my list of options for my sendable chooser? So I can select it and then select autonomous.
You type chooser dot add option.
Okay.
Wait, hang on. It's trying to get me to put add child. Okay. And then turn time.
What do you mean turn? Can you be more specific? It takes
Oh,
in
wait,
the
what?
string and the command, right? Okay, so turn time in quotes. And then what? That's going to be the menu name. This is when the stuff in quotes is going to be what's in our menu, comma, the object name. Exactly right. So now I want you guys to go run this. This is not going to turn. So our expectation is that this robot just moves in place. It turns in place for 3 seconds. I know that it's not going to do that. I want you guys to go try it, come back, tell me what it does, and how we should fix it. And that's the last thing we'll do today. Once we fix it, we can sign off and we can go enjoy our Saturdays. Were you able to run it, Alexa and Eden?
Well, I tried running and then it didn't do anything.
It didn't do anything? Are you sure it didn't do anything? Did you select autonomous? Are you
Yeah.
connected to the Wi-Fi? Is your robot on? Okay, no problem, Eden. Take your time. Unmuted, hold on. So what happened, guys? Still working on connecting?
Yeah, I am. I'm pulling it up now.
Awesome.
Okay, so it started spinning and it hasn't stopped spinning.
It hasn't stopped spinning. Can you show me what your turn time class looks like? I'll stop sharing. Because we know at the very least it should stop spinning after 3 seconds. Okay, and you're certain it didn't stop spinning.
Yeah, I just had to disable it to make it stop spinning.
Can you try it again?
Yeah.
Okay, yeah, she's still spinning.
Still spinning?
Yeah.
Oh, I see. I see what's wrong. Look at your is finished return statement. What's up with that? What are you saying? Start with return.
This one?
Yeah.
Wait, what am I looking for?
Just tell me, can you describe in plain English what's going on with line 32? Start with return.
So wait, it returns the current time.
You skipped something. What's before current time?
System,
And what's before system?
the dash,
What does the dash represent in math?
subtract.
We're doing math right here, right? Yep.
Yeah. Okay.
So you essentially set the left side of your comparison to negative. So it's never going to be greater than or equal to this dot time because this dot time is positive.
Okay.
So it's going to turn infinitely.
Okay.
Do you understand what line 32 does otherwise?
Yeah.
Okay, cool. Try it again.
Um,
You didn't save, by the way.
okay, it worked.
Awesome. So your robot didn't do anything weird?
No.
Can you put it on a hard surface and try it?
Yeah, it's acting well now.
Okay, so technically, if it was turning, both of these wheels would be moving in opposite directions, right?
Oh, okay.
If it moves
Right.
in opposite directions, then it should turn on its axis instead of making a big loop.
Okay. Do we have to do it again then in negative? Like the opposite direction?
No, so I'll give you a hint. Line 28 is wrong. Let me try to explain what how Arcade Drive works, okay? In terms of how you've written it in line 28. How we all wrote it in line 28. I don't have to. Let's wait for Eden to come back. Eden, how'd it go? Bless you. How'd it go, Eden? You have a syntax error that you can't figure out. Can you give me a snippet of the syntax error, paste the part that it's erroring on, or describe it verbally? I unfortunately need more information than that. I can't help you figure it out without having the context. Maybe missing a semicolon somewhere, or maybe missing an open curly brace or closing curly brace. But past that, I can't give you more advice than that. Feel free to paste it in the Romi chat or paste it in a Zoom chat or share your screen. Any one of those will help you diagnose it. Okay, so you see how you hover, how you've clicked on it and it highlights the opening curly brace? It's opened the opening curly brace on line 8. So this closing curly brace means that you've ended your class on line 13, because on line 8, the opening curly brace indicates the beginning of your class. Okay, great. Do you see any other errors? Scroll all the way down, make sure there's a closing. So now you don't have a closing curly brace for your class. Perfect, you got it. I didn't even need to explain it. And you're gonna do the tabbing required. Great. You're way ahead of me. Great job. Perfect. So theoretically, you should be able to run this now. So before you drop off, Eden, let me just explain, since we're over time, let me explain what's wrong with our code and let's see if we can fix it, and then you can go and mess with it on your own. So I'm just going to be straight up with you guys. Line 29 is wrong. We want this Romi drivetrain to turn in place, right? So if we think of arcade drive in terms of a car, if the first number is how hard we're pressing down on the gas pedal, meaning we're pressing down on a gas pedal at this dot speed, and then the second number means which way we're turning our steering wheel, meaning 1, we've turned it all the way to the right, and -1, we've turned it all the way to the left, and 0 meaning there's no turn. Then we're not going to turn in place here. We've hit the gas and we're turning. We've hit the gas at this dot speed and we're turning at 0.5. So if we want to turn in place, how should we modify line 29? We're not wanting to drive forward. We're just wanting to turn.
Would we do 0 instead of this dot speed?
That's exactly right. We do 0 because we don't want it to go forward. We just want it to rotate. So instead of 0.5, what should we do here? Because we want it to rotate at a certain speed. We don't want to just arbitrarily rotate at 0.5.
Would it be 1?
No, we've passed in the speed we want it to rotate at. So it's just a matter of taking that speed we've passed into our turn time class. And I don't have chat open again, I'm sorry. Let me open that up. Well, now where's chat at? I've lost the chat screen. Yes, it is 0, this dot speed. You're exactly right, Eden. So now this, we're not giving it any throttle, so it's not going to move forward or backward. It's just going to rotate in place. And that's different than drive forward. Drive forward is the exact opposite. We just want it to go forward. We don't want it to turn. So we pass in this dot speed for the x-axis, what do they call it? X-axis speed. And we give it no rotation value. In turn time, we give it no x-axis speed, but we give it a rotation value. So I want both of you guys to go test this out real quick, confirm that it works, come back, give me that confirmation, and then we can end the lesson there. Hopefully that made sense. Let me know if you guys have any questions.
Yay, it worked.
Did you say it worked?
Yeah.
Does it turn in place, Alexa?
Yep.
Awesome. And it doesn't do that big wide loop again, right? It just
Nope.
rotates on its axis.
Mhm.
Perfect. I guess the difference in my metaphor, the reason why my metaphor is wrong is if in a car you want to rotate, you have to give it gas. In this case, you don't have to give it gas for it to rotate. The rotation and the drive forward are independent from each other. So if you give it a rotation value, it'll still rotate. So that was the wrong metaphor, and I'll stop using that metaphor.
You're
Okay.
Eden, go try it out and let us know if it works. And then we can end the lesson.
I have to leave actually.
Okay, great work today. Have a great weekend, and I'll see you next week.
Okay, bye.
Bye.
next week is Git, or is it gyro?
I was going to do command chaining and Git, but I can also do gyro. Either one.
I'll leave it up
The problem with gyro that I have is in the example that they give, it's all using sim doubles, and I can't quite figure out how I'm supposed to explain sim doubles and how it's a simulation of some WPI lib libraries and what all this is doing. Like, I just want to give them this class and tell them, like, don't worry about any of this stuff. All you need to understand is get rate X or get angle X or whatever.
Yeah. Because this is where it kind of diverges from an actual WPI lib robot, because all that is handled in the not the Romi gyro class, but the WPI gyro class.
Yeah, exactly. This is just like a wrapper to get some like internal values in the Arduino board. So it doesn't even look like a real gyro class that we'd use. So I think I'm for the gyro lesson, I'm just going to give them this class, and we'll talk about what all the methods mean and tell them not to worry about what the heck a sim double is.
The important thing about the gyro is getting it to go to a position so we can start talking about error and control loops and
yeah, exactly. So I think what we'll do is do command chaining, do Git, and then we can move on to gyro and do turn degrees and all that fun stuff. And then we can get to PID.
So I'm stopping the recording because I'm betting Eden's going to get it.